Hi, thank you for attending Ortelius Microservices Visionaries 2021. This is the presentation for Know Your Blast Radius. Next slide, please. Okay. Ortelius Open Source. Ortelius is a microservice management platform that versions and tracks microservices, their blast radius, and inventory across clusters, providing a proactive view of your microservice architecture as it changes over time. Ortelius is an incubating project under the governance of CD Foundation, and uh, our mission is to simplify the adaptation of microservices through a world-class microservice management platform driven by supportive and diverse global open source community. Okay, I am Atul Tiwari. I'm the newest member of Ortelius Open Source, and I'm in my final year of graduation. And Ortelius is the very first open source community that I've joined. So our presentators are Bimi and Muni. Bimi and Muni both are from Nigeria. They came to Ortelius through the She Code Africa program, which is a boot camp for specially designed for women by Ortelius Open Source.
Hi everyone, this is Bimi. I'm a data scientist and I'm a part of the Ortelius open source community. And Ortelius is actually my very first open source community. This is the first time I'm working as a open source contributor, and I've been enjoying myself. Today we are going to be talking about knowing a microservice blast radius. So I'll be talking about this with Muni. I will take in the introductory part of it, just explaining what a blast radius is and why you should understand your blast radius, and then Muni will take us through how Ortelius helps you to manage your blast radius, and I'll just going to take it from there. So I'll start by defining what a microservice is. Microservices are independently deployed objects moving across the pipeline in very high frequency. And the microservice blast radius shows how an update of an independently deployed service or component impacts the dependent application. We're also trying to break it down step by step. For example, when developers are working with microservices, when they want to make an update to a service, they are worried a lot of times because they are unsure of the applications that will be affected by these updates. So understanding what the blast radius is understanding exactly the application that will be affected. When developers are working with microservices, they are not very confident when they are pushing updates and making updates to their services because they are unsure of all the applications that will be affected. And because of this problem, the usability feature of microservices are not fully enjoyed. So because they are not sure of how scalable these microservices, they end up not using them and just dump them after the very first use. And Ortelius, this is an example of what a blast radius looks like. So this is a microservice here in the middle. CAT service version 122.150 is a microservice, and the Ipstar store, Labor Day, Ipstar store, Labor Day sale, and Ipstar store July 4th sale are the blast radius. These are the applications that can be affected by this CAT service update. So there's an example of a blast radius. This was gotten from Ortelius blast radius map. And okay, so the problem definition when you don't understand what your blast radius actually means is because microservices is basically trying to move away from monolithic process practices to doing microservice architecture. But if you do not understand your blast radius, you end up going back to monolithic processes by tracking your microservice individually. So you start updating your applications one by one, and that is not what they're trying to do here with microservices. So when you do not know your blast radius, you cannot consistently predict the success of a microservice release. And out of necessity, teams begin to request their own clusters and namespaces to isolate their applications and control what is updated. So you find out that maybe you have different teams in the same environment. Everybody starts saying, okay, we'll manage our own service by ourselves and things like that. And you go away from the original plan of the microservice architecture just because you do not understand and don't know your blast radius properly. And this whole thing is basically summed up to two problems. So there are two problems when you don't understand your blast radius completely. There's a microservice sprawl and a microservice drift, and I'll go to the next slide now. So, okay, for microservice sprawl, a lack of visibility into the usage of a single microservice across all of your clusters is a dangerous condition. When you do not know your microservice blast radius, you want to avoid an adverse impact to end users. So you are left with some undesirable options. One option is to run back to monolithic practices even in a cloud native environment, maybe using Kubernetes namespaces to silo applications configuration. What this basically means is when you are a microservice floor, imagine you have 3 clusters and all the 3 clusters use the same services. What you end up doing, because you don't know your blast radius, is by repeating the same services all over again in 3 different places. So you end up having, imagine you have 4 services under the 3 applications, you end up having 4 services because you are duplicating services in all the different clusters. I know that's a little bit confusing, but I have a picture in the next slide to show you exactly what that looks like. And microservice drift usually occurs when there is microservice sprawl, because then you update a service in an application and then you forget to update it in another application, and then you see that your services are no longer in sync. One is behind and one is way ahead in version. So let me go to the next slide and show you what this looks like. So this is an image, and in this image we are managing 3 clusters, 3 namespaces, 12 pods, and 1 environment. So the pods are the services. So this is the first cluster, this is another cluster, and this is another cluster. And you can see that they all have the same services. We have the front-end service, the cart service, the shipping service, and the payment service. And we can see that they are repeated all across the 3 clusters. So this is what microservice sprawl looks like. So instead of having just one thing managing the 4 services for us, we're repeating our service in every cluster. And that becomes problematic because instead of managing 4 pods, we end up managing 12 pods. And microservice drifts now happens when, okay, we try to update the shipping pod here from version 3 to version 4. So we updated it in candy store cluster and in toy store cluster, but we forgot to update it in the clothing store cluster. And this now causes a drift because now candy store and toy store are now ahead of clothing store cluster. And we now say that the shipping service drifts at the clothing store cluster. And those are the major problems that not understanding what your blast radius looks like would cause. So I wasn't okay. So that is all for me. I hope you understand what the problems from not understanding your blast radius would look like. And I'm going to pass it on now to Moni to take us through how Ortelius has managed to solve this problem and help you manage your blast radius. Thank you.
My name is Moni. I am a data scientist / data engineer. I joined Ortelius open source through She Code Africa. I was talking about the solutions to the problems that were defined previously by Bimbo. So here is explaining implementing a shared service-oriented architecture. As Bimi has explained earlier about knowing your blast radius, the importance of knowing your blast radius, and the problem that it could cause, I'll just go through how Ortelius solved this problem. First, explain the shared service-oriented architecture. So here it says to minimize the number of resources required and reduce the microservice sprawl and drift. We need to understand what teams are using which services. So basically, Ortelius tracks the applications that are using your microservice. Therefore, you don't have to update every application when the microservice changes. This architecture reduces the microservice sprawl and the drift. So you don't get to have a sprawl or a drift if you are using this architecture. That is moving away from the monolithic approach where you have to update each application individually. So a shared service reduces the complexity of microservice by eliminating the confusion caused by the drift, like I previously explained. Most importantly, a shared service architecture ensures that critical updates of the shared services are being consumed by all teams. A single release fixes the problem for all teams. So if all the application used by a microservice is connected to it, once the service is updated, the applications are automatically pick up the updates and work with it. Therefore, you won't have any cause of drift or sprawl. Next slide, please. So this diagram shows how the drift and sprawl problem is eliminated. Previously, we saw that each cluster had separate services in it, and one of the cluster was not properly updated to the new version. But here in the shared architecture service, um, using the shared architecture service rather, this is an example of an online store company cluster where there's a candy store, there's a clothing store, and there's a toy store. Yet the three namespaces are connected to a central namespace. In this namespace now, they have different services. They have the shipping version 4 part, they have the payment, and the cart service. So it shows that there was previously a version for shipping, which was version 3. And there's a new release for shipping, which is now the version 4. So automatically, the candy store, toy store, and the clothing store updates. It picks up the updates from the shared services. So there's no sprawl or drift here. The problem has been eliminated by using this service architecture. Next slide. So that is ultimately Ortelius' solution to knowing your blast radius. So this diagram shows that we have different services, and different services could have different versions. Looking at the front end service, we have a version 1_2_8. We have another one of version 1_2_9. So either of these versions can be used. So you can have several versions for your you can have several versions of the services. So you just have to select which version you're currently using, and it automatically updates all the application that uses the services. Also, same thing applies to cart services, where where it has two versions here. But this diagram currently shows that it is using version 1_2_2_149. So either of the version will be selected and it will be used by the application. So the application we are looking at here is the Hipster Store July 4th sales. So under the Hipster Store July sales application, we have all of these components which are managed by Ortelius. That is, if there's an update in any of these services, it automatically is applied to the Hipster Store July 4th sales and any other application that uses this service. Next slide, please. So Ortelius also keep track of the versions of the services. So here we have the card service. We have the two versions of the card service. We have the version 1_2_2_149. Excuse me. And you have card service version 1_2_150. So here you can see the service, the version of the services that you've had all through and keep track of it. Next slide. Yes, so this is the Ortelius blast radius map. So the orange box is the service that is being shared by the application. The applications are in the pink boxes. So the Hipster Store labor sale, the Hipster Store labor day sale, and the Hipster Store July 4th sales, they all share this service, the card service. So here it shows that if this card service is updated at any point, all of this application will also be updated. It will be updated in all of these applications. Thereby, you don't have to go into individual applications to update this service since it is connected centrally to the service. So all you need to do here is update the service, upload it to, deploy to Ortelius, and each of the application uses the service. Next slide, please. Yeah, okay. So the application versions, Ortelius shows the versions of the application. So once a new version of the application is created, it automatically shows here. You see the different version as it progresses. We could have several applications. There's several versions for each application. Like here we have Hipster Store July 4th sale. That is the base version. And then we have Hipster Store July 4th sale. We have another version. We have version 1_2_9. So it was initially deployed to CI/CD test cluster to pipeline to test the services in the application, and then it was deployed to Hipster Store cluster finally after the test. So Ortelius tells them ahead of time that a new release is out, and then it sends a CI/CD pipeline for tests. So that's why we have the CI/CD test cluster first before it was deployed to Hipster Store cluster. Next slide. Also, Ortelius shows the difference in an application. If a service is updated in an application, you can easily track the service that was updated. So here it shows that we previously have Hipster Store cluster, then we had Hipster Store July 4th sale. So the difference between the Hipster Store cluster and Hipster Store July 4th sale is the card service. So this means that the card service was updated or a new version was released, which is what is the difference between the Hipster Store cluster and the Hipster Store July 4th sale. Next slide. So summary of the maps here shows we have the BOM report, we have the blast radius report and the difference report. So the pink boxes are the applications in the BOM report, and the orange boxes are the services. So we could have several services that are shared by different applications. Yeah, it shows that I think most of the services here are used by both applications, except for load test cases down here and load generator. Then all of that application, most of them. Okay, I think ad services too is used by just web store label. So all other services are being shared by both application, both the web store July and the web store. So this shows that you can track the services that an application is using, and you don't have to you are not going to have a situation of a drift or a sprawl, because once either of the service is updated or a new version is released, then you get a notification that a new release is out, and it sends it to a CI/CD pipeline for tests. Then it finally gets deployed to the application. Also, the blast radius report shows the for each of this is like the BOM report is showing generally which application is using what service, yeah. But the blast radius report is per services. So we are looking at CAT service here. These three applications are using the CAT service: the Hipster Store Labor Day, the Hipster Store July 4th sale, and the Hipster Store Labor Day sale. Yeah, so, and also there's different reports. like I said earlier, it shows the difference between an older and a newer version of an application. So what this says here is the card service is what is different between the Ipsos Store cluster and the Ipsos Store July 4th sale. Next slide. Finally, this is Ortelius pipeline. So stage one here shows that there's a container registry push. So here the clients have the microservice deployed, pushed to the container pushed, and then it goes to Ortelius. Then once Ortelius gets the new update, it schedules either on demand or CI/CD triggers the deployment. So sometimes you have to schedule the deployment out to the applications, or yes, it might be on demand, or after the test on the CI/CD pipeline, it just automatically deploys to the applications depending on which one was selected. Yeah, next slide. And that is all from me. Thank you.
Thank you, Bimi and Muni, for this informative presentation. I have a few questions of my own. Can you please tell me what a microservice sprawl is?
Hi, I'll be answering that question. Let me just take us back to slide where I explained using an image. Makes it really easy to understand using this image. So we have three clusters in one environment. Three clusters: candy store cluster, clothing store cluster, and toy store cluster. They all belong in one environment. And they all use the same service, the exact same services, they all use them. A sprawl now occurs when, even though they are using the same services, we have to repeat the service in each cluster. So we have we have three services. We have the front end service, the cart service, shipping service, and payment service. For each, if you look through, they all have the same services. But because we have a service flow and we don't know our blast radius here, we are repeating the services all over and all over again. And we should not have to do this. So using the Ortelius shared service architecture, we can just have all the services in one big box here and all the clusters are connected to it. So a sprawl occurs when we separate our services into different clusters. That's what a sprawl is.
Okay, and also, how does Ortelius determines the relationship between services and applications?
Okay, I'm taking that question too. From what Muni told us earlier, there was the bomb report. That was very, very straightforward. So this bomb report, so at the beginning, maybe at onboarding with the client, Ortelius goes through and asks for all the applications and all the services that the client uses. So Ortelius already records like this, like a bomb report showing all the applications in the pink boxes and then which services they use, which ones they don't use, and so on and so forth. So Ortelius already documents all this and then updates it in the backend relational database. So Ortelius keeps it locked down. Just at onboarding, they ask you the important questions. What applications do you have? What services do you use for these applications? And that's how we keep track of the blast radius.
Okay. Okay, so my next question is from you, Muni. Does Ortelius determines the differences between two deployed versions of a microservice?
Yeah, that's a very good question. Ortelius notifies a change. It notifies of a change. So it once there's a change in the version of the services, it passes it to the CI/CD test cluster where it tests for any bug in the service and then notifies before it finally gets deployed. Thank you.
Thank you, Bimi and Muni, for this presentation, and thank you all for watching.